So continuing with the circle and periodic functions, 11.6. We're using the properties of the periodic functions to evaluate trigonometric functions, and we're looking at a real-world example. So we have one here on page 785. It says cycling. So refer to the beginning of the lesson. So I'm going to put the information in the table. So it says make a table showing the height of a bicycle pedal at 0. So we want it 0, 0.5 seconds, 1, 1.5, 2, 2.5, and 3 seconds. Now, we know that at 0 seconds, the pedal is 18 centimeters high, and at 0.5, it's 11 seconds. 11 centimeters, and at 1 second, it is 4 centimeters. So at 1.5, it reaches 11, and then at 2 seconds, it's back at 18. So 2.5, it's rotating again, and at 3, it is at 4. So the first thing we do is make a table showing the height, and then we have to identify the period of the function. So we're looking for when it repeats. So if we look, we've got here, this is where we start, 0, 18. And then at 2 seconds, it is back to 18. So it's done a full rotation. So the period where it's repeated is 2 seconds. Graph the function and let the horizontal axis represent time and the vertical axis the height. Okay, so then we need to graph this function. So this is the height of the pedal. So let me just do that again. So we have the height in centimeters, and this is the time in seconds. So 18, so we've got 0, 18, so I'll say that's about there. Let's just do a point instead. So 18, and then 0, 5, 11, so it's about there. And 1, 4, 1.5, 11, 2, 18, 2.5, 11, and 3, 4. So if we can try as smoothly as we can. Not quite. And let's try that again. So through the points. And then this would go back up. So there's our graph. And we can see this point here. This is where our period of 2 seconds. So this question, guided practice, it says another cyclist. So another cyclist pedals the same bicycle or bike at a rate of 1 revolution. So that's 1 complete turn. per second. So we need to make a table to show the height. So if we create a table like before, and we'll have the time is in seconds and the height is in centimeters. So the time is going to be the same. It says here 0, 0.5, so 0, 0.5, 1 second, 1.5, 2, 2.5, and 3 seconds. So the height, the question says a full revolution in 1 second. So this is going to be at 18, and then in 1 second it's going to be 18 again. And then at 2 it will be back round to 18 again, and at 3 it'll be back round to 18 again. Now the other position at 0.5, this is going to be back around halfway. So this is going to go down to 4. So this will be 4 and this will be 4. Because the diagram shows us that the height of the pedal is 18, and when it's gone round halfway it's going to reach 4 centimeters from the ground. So now we need to look to draw this. Okay, so we've labelled our drawn our axes, and this is going to be the height. So we're going up in 5s, and then across the bottom is our time in seconds. So let's have a look at our diagram. So 0, 18, and then 1, 18. So this is our full cycle. So the period is from 0 to 1, so the period is just 1. And if we draw this, 0, 18, so there's 18. So this is going to come down to 0. So this should be labeled this wrong. Apologies. 0, 0.51, 1.52, 2.53, and we're not going that far. There we go. So 0, 18, and then 0.54, 1, 18, 1.54, 2, 18, 2.54, and 3, 18. So this is, it's going to come around, let's do it accurately. So we can see here that the period, and it repeats.